Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 5, Lesson 2, Variables and Expressions. So this is our first unit really on algebra in Math 7. And there is probably no other ideas in all of algebra more important than that of a variable and an expression. So let's get in right away, review what those two ideas are and how we can use them in this first lesson. So here we go. Variables are just letters that stand for unknown or changing numbers, right? Variable literally means something that is changing, right? Expressions, on the other hand, are combinations of variables and numbers using operations like addition, subtraction, multiplication, division, exponents, fractions, things like that, all right? So a variable is a letter that stands for a number that we either don't know, right, or that's changing. And expressions then are combinations of those variables with other variables and other numbers, that then are useful for something. Let's take a look at exercise number 1 and jump right in to working with an expression. Given the expression 3n plus 7, answer the following questions. Letter A. If n is equal to -2, should we first add 7 to n or multiply n by 3? Explain. All right, so I'd like you to think about this, right? In this calculation, we've got a multiplication by 3, and we've got an addition of 7. And the question is, if I supply you a value of n, not necessarily n equals -2, but any value of n, what should we do first? Should we add the 7 to the n first, and then multiply by 3? Or should we multiply by 3 first, and then add the 7? Pause the video now, and see if you can remember what the answer to A is. All right, well, we should multiply by 3 first, and that's simply because multiplication comes before addition in our order of operations. All right, so let me get that down. We should multiply first due to, hey, I don't know what happened there, order of operations. All right, so order of operations says multiplication and division definitely come before addition and subtraction, so we should not add first unless there were parentheses. And side note, there are no parentheses. So letter B. Evaluate the expression when n is equal to -2. Show the substitution of the value. You should always do that. Whenever you're given an algebraic expression, which is just an expression that has at least one variable in it, and you're asked what the value of the expression is, that's what it means to evaluate, to give the value of. Evaluate means to give the value of, right? Then when I substitute that number in for the variable, I should show that. All right, so here we go, right? I'm going to take my n equals -2, and I'm going to substitute it in there. And very often when I've got this kind of multiplication going on, I'll show that multiplication with a very strange looking 3 and by putting the -2 in parentheses. All right. This now tells me that I should do this first. 3 times -2, a positive times a negative is a negative, and that's -6. And then -6 plus 7, right? We've got some cancellation going on there, gives me just a +1. All right. So this is actually no different than a problem you would have done in 6th grade math. We definitely evaluated the lots of expressions for lots of input values. The big difference in this problem, and in Math 7 in general, is that we can now bring in negative numbers as well. So keep in mind, a lot of what we do today is going to be giving you a workout with sort of negative numbers. Like here, a positive times a negative is a negative, and then 6 negatives with 7 positives added together gives us a net +1. All right, just a little bit of signed number review there. Okay, so let's keep going. All right, order of operations are absolutely critical when evaluating algebraic expressions. So let's do a little review about this. Order of operations, oftentimes abbreviated as PEMDAS, or please excuse my dear Aunt Sally, or some other things with elephants and stuff like that. I don't know all the different acronyms, but at the end of the day, when we're looking to evaluate an expression, right, then what we should be doing is first evaluating anything within parentheses, Then we should evaluate any exponents that occur. Then we should do multiplication and division going from left to right, and then we should do addition and subtraction going from left to right. All right? So the absolute last thing we're ever going to do in one of these things is add or subtract, unless that addition or subtraction occurs within parentheses. But we'll kind of see some of that along the way. So let's take our order of operations in exercise 2 and evaluate just a bunch of different expressions. Here we go. Let me read through exercise 2 for you. For each of the following expressions, evaluate it for the given value of the variable using order of operations. In each case, be sure to show your substitution. All right, so we've got all sorts of stuff going on here, right? We got some exponents, some division with fractions, more fractions. All right, so anyway, very, very simple, right? I'm going to evaluate 10 plus 5x for x equals 2. Right? What I'm going to do in this kind of problem is I'm going to take my x equals 2, I'm going to substitute it in for x, right? Very often I'm going to put whatever value that I substitute in parentheses, especially if there's some multiplication going on. And then the real key here is I've got to know to do the 5 times 2 first and not the 10 plus 5 first, right? So that multiplication has to come first, and therefore I'll get 10 plus 10, and that will be equal to 20. Nice value there. All right. Let's do another one together and then maybe have you do the other two on your own. Right here we've got 2n to the second minus 7 for n equals negative 3. All right. So again, I'm going to take that value of negative 3 and I'm going to substitute it in for n. That's going to give me 2 times negative 3 to the second power minus 7. Now again, the first thing I've got to do here is figure out what this is. Negative 3 to the second power is negative 3 times negative 3. And a negative times a negative is a positive, right? So negative 3 squared is going to be 9. All right, now I have to do this multiplication next. 2 times 9 is going to be 18. And the last thing I'll do is this subtraction. 18 minus 7 is equal to 11. All right. You should definitely have scrap paper on the side of your sheet, you know, in case you need to do a little bit of this calculation and you don't have the room for it on your paper. All right. Keep in mind all of your rules in terms of negatives and positives. Things like a negative times a negative is a positive, a negative divided by a negative is a positive, etc. All right. So what I'd like you to do now is I'd like you to do some substitution in these two, come up with values, see what you get, follow your order of operations, and then we'll go through them. All right, so in a situation like this, right, let's put that 4 in for the y here and the y there, and let's see what it looks like. Here we go. All right, so I'm going to have 9 times 4 minus 1 in the numerator, and then I'm going to have 4 plus 1 in the denominator. Now in the numerator, I have to do that multiplication first, so 9 times 4 is 36. And in the denominator, I'm just going to leave it as 4 plus 1 for the time being. I can now do that subtraction in the numerator, and that's going to be 35, and do that addition in the denominator, which is going to be 5, and now 35 divided by 5 gives me 7. All right. By the way, notice in this particular situation, right, that we work through what the entire numerator is, which is 35, and the entire denominator, which is 5, before we do that final division. It's almost as if there are parentheses sitting around the numerator and denominator. And there kind of are. They're what are called implied parentheses. In other words, you know, we're not going to like do the 9 times 4, get a 36, and then do 36 divided by 4. Okay, we're not going to do that. Okay, because really we have to do all the operations in the numerator, all the operations in the denominator, and then divide the two numbers that are the result of whatever's in the numerator and denominator. All right, let's take a look at letter D. This one gets a little bit ugly because of the fraction, but that's okay. We can still do that substitution. We're going to get negative 4/3 times negative 12 plus 5. Now the trickiest part here is to just multiply the negative 12 by the negative 4/3, but keep in mind that when we multiply a negative by a negative, we get a positive. I'm going to put a positive symbol there, even though I don't really need to. All right, but a negative times a negative is a positive. We can then do a little cancellation, right? 3 goes into 12 4 times. Then I have 4 times 4, which is 16. Right? And again, it's a positive 16 because we've got a negative times a negative. 16 plus 5 is then 21. Now, you could use your calculator to help you out with many of these things, but I would suggest, because I've tried to keep the numbers small and very sort of user-friendly, if you will, I would suggest doing it without your calculator so you get more practice on signed number manipulation, i.e. positive and negative number work. All right, it's very important to keep reinforcing that throughout this course, given that Math 7 is really the first time you work with the arithmetic of negative numbers. All right, that being said, let's keep going. All right, let's look at a special example, right? Exercise number 3. For the expression 5x plus 2y minus 7z, do the following. Letter A, evaluate this expression when x equals 2, y equals 10, and z equals 5. Show your substitution. All right, well, this is actually fairly simple. What I'd like you to do is pause the video now, figure out what this expression is equal to when we substitute these values in for the 3 variables that make up this expression. Go ahead. All right, well, let's take a look. So, simple enough, right? Same thing as before. We're going to put 2 in for x. We're going to put 10 in for y. And we're going to put 5 in for z. Now, our order of operations say we have to do these products. 5 times 2 is 10. 2 times 10 is 20. 7 times 5 is 35. All right, order of operations now says I should add these two together, which gives me 30 minus 35, and 30 minus 35 will be negative 5. Be careful there, 30 minus 35 is not positive 5, right? As we looked at just the other day, subtraction is not commutative. You can't flip-flop them, right? It's just going to be negative 5. Now, letter B. Which operations did you do first, and which did you do last? Well, let's talk about this, because this is actually the big point of this one. It's not really to get the value. It's this idea that what we did first in each case was the multiplication, right? That was what came first. And what came second was the addition and subtraction. Now you might say, well, the subtraction came last, which technically would be correct. But really what I want to get at here is that the multiplication comes before the addition and subtraction. And if there was division, that would also come before the addition and subtraction. Now, why is this important? It's important because it gets into something that we call a term. And terms are just combinations of variables and numbers using multiplication or division. They're always separated by addition and subtraction. Now, terms get more and more important as you go on in math, all right? But it's interesting because, let's take a look at exercise number 4. It says, for each of the following expressions, state all of its terms, right? So you could look at letter A and you could see a 4 and an x squared and a 7 and all of that and think, oh man, this has got like 3 terms, maybe 4 terms. I see a 4, an x, a 2, a 7, right? Well, that's actually not true, right? This thing only has 2 terms. One term is 4x squared and the other term is 7. Right? So it says for each of the following expressions, state all of its terms. The 2 terms here are 4x, and I'll just separate them, and 7. A term doesn't have to have a variable in it. All right? The real key with terms is to look for addition and subtraction. That's what's going to separate our terms, right? Remember, addition and subtraction come at the end. So the reason for terms is that we sort of start thinking about 4x squared as being a single thing, a single algebraic thing. And it's being added to the 7, or maybe 7 is being added to it. It really doesn't matter. Addition is commutative. And it's the same idea here, right? Here we actually have 3 terms. We've got a term of 12x, a term of 2y, and a term of 11, right? And again, the idea here is that, oh, all right, well, I took the term 12x and I added it to the term 2y, and then I subtracted the term 11. right? So we're adding and subtracting terms from one another, and eventually we'll start to interpret what terms are, what they mean in the real world if there's some kind of word problem or context to what's going on. All right, now we've done A and B, and this isn't too difficult. So what I'd like you to do is pause the video now and see if you can write down all the terms for each one of these expressions, and I would suggest starting the way I did by just circling them. Pause the video now. All right, well, this is what we call some easy math, right? So letter C, right? Here we've got a term. Here we've got a term. Here we've got a term. So our three terms are 3y squared, 2 times x times y, and x squared. Again, this is a very good example to kind of look at this one, right? A term is a combination of variables and numbers using multiplication or division. So I have 2 times x times y. That's all multiplication. 3 times y, right? All y squared is a way of saying y times y, so that's all multiplication. X squared, that's x times x. That's all multiplication, all right? So you got these three terms, 3y squared, 2xy, and x squared. Right? Likewise, letter D, lots of terms here. All right, we've got 4x cubed, 2x squared, 7x and 10. Here we've just got something pretty simple, two terms. We've got x squared and y squared. Here we've got three terms. X divided by 2, remember terms can have division in them. 3 times z and 6. All right, yeah. Sometimes I cross my z's. The reason I cross my z's sometimes is so that you don't confuse them with 2's. And I was just looking at that thinking, that kind of looks like a 32. Anyhow, it's just particular with z's. So terms, very important. Now what's interesting is that terms are so important that we actually give special names to expressions that have only a certain number of terms. And these names are pretty understandable. A monomial is an expression that's just a single term. A binomial, as probably many of you know, bi means 2, right? A binomial, right, is an expression that has two terms, like 2x plus 10. And a trinomial is an expression with three terms, like 3x plus 2y minus 7. Okay, so our last exercise of the day, pretty similar to our last one. Let's take a look at exercise 5. For each expression, circle each of its terms, and then state whether it is a monomial, a binomial, or a trinomial. All right, so this is kind of cool, right? Let's do the first two together, and then we'll turn you loose to do the rest of them. You know, in this first expression, 1/2 times x minus 3, we can see that, here's one term, here's two terms. Because it's got two terms, this is a binomial. Okay, bi meaning two. Bicycle, right? Biped, if you know that term. All right, let's take a look at letter B, right? Here we've got 4c squared, 2c, and 5. This has got three terms, so it is a trinomial. Okay? So what I'd like you to do is finish off the 4 remaining problems, figure out how many terms there are, and then tell me whether it's a monomial if it's got one term, mono, binomial if it's got two terms, trinomial if it's got three. Pause the video now and finish this up. All right, well, let's do it. In letter C, we've got 1, 2, so this is a binomial. All right, letter D, that's it. That's my only term. This is a monomial. Letter E, 1, 2. This is a binomial. And letter F, just that thing. And this is a monomial. I guess I should have maybe had an additional trinomial up there, but there's only so many examples you can have. Anyhow, so just terminology. And it's important because, you know, I might say something like, let's multiply this trinomial by the following monomial. And you don't want to be like, well, I don't know what he's talking about there, right? So when we talk about monomials, binomials, and trinomials, we're simply referring to how many terms they have or how many like collections of monomials they have, right? Because a monomial is a single term. All right, let's wrap this up. So today what we did is we looked at variables and expressions, and these are certainly things that you've been exposed to for the last couple years, right? A variable is just a letter. It stands for some number I don't know, right? And an expression is sort of a calculation that involves variables and numbers. Then we give these special names, to things like terms, which are collections of variables and numbers using multiplication and division, and that are separated from other terms by addition and subtraction. And further on, we've got that monomial, binomial, trinomial kind of way of naming how many terms a given expression has in it. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.